Yep. So my name is Dimitris Papitsis. As you mentioned, I'm based in suburbs of Seattle, Washington, United States. I am let's say a niche collector in the sense that I only collect the large Hermes heads of Greece. I don't even collect other periods of Greece. I purposely selected this area. Well, to be honest, not purposely. It was a matter of chance, but I stuck to that area because I thought it was very challenging, and challenging is what usually excites collectors. Challenging in the sense that large Hermes heads of Greece have particular difficulties in terms of classification and identification of the different printings and the different varieties. Um, as I said, I'm based in outside of Seattle, Washington, United States. I work for Microsoft Corporation, and today I'm going to be presenting. Mostly, the presentation is going to be around using artificial intelligence to classify the large Hermes head stamps of Greece. This is the service that's hosted by Microsoft, and we're going to be delving into it in a little bit. What I will also want to say is that this is a project. This is not a finished product by any means. This is a project that I have been working on since the last, I believe, 1.5 years or something, where when I first learned and saw how this works, and I thought it could be used for philatelic purposes as well. So that's about me and the hobby. I'm planning to. So the reason is this is still a project or not a finished product is that at the same time I was tackling a different project, which is writing a book about large Hermes heads, which I'm going to speak very briefly about. And this is what took a lot of time for me away from this artificial intelligence project. But you're going to see the difficulties of both manual classification and both and classification using artificial intelligence and how these can be potentially combined as well. Alyssa, I'm ready to start with the presentation if we're okay.
Dimitris, please go ahead. Lovely. Thank you very much. Please do.
Awesome. Thank you. Is it visible, the presentation, the slides?
Yes, we can see your slides. Yes, I can see your first one. Yes, lovely.
Awesome. Thank you.
Pleasure.
So today's presentation, large Hermes heads classification using artificial intelligence for virtual stamps. It's 2024. Let's move on. So the agenda for today, I'm going to do a small introduction about the large Hermes heads of Greece, the first postage stamps of Greece. I'm going to show a few slides very quickly about the printings themselves, which started in 1861, and the last ones were printed around 1886. I'm going to talk a little bit about a unique features that the stamps had, which is the control figures or control numerals or control numbers at the back. I'm going to go a little bit into a detail later about the printings. I'm going to talk about the classification issues and why it's difficult to classify the stamps and why artificial intelligence could potentially help in that area. And then we're going to go to the meat of the whole presentation, which is using AI in LHH classification. Of course, do a demo of how that thing works in action. So, small introduction to large Hermes heads of Greece. These were the first Greek stamps. The official circulation period started in October 1, 1861, lasted until 1886. They have a lot of unique features, to be honest. The first one is that they were continuously printed using the same design, the same plates, one per denomination, never used any others, for 25 years, based on the current postal needs, which means that there were no distinct printing periods. All the printing periods you're going to see later on are based on classifications that philatelist did to make it easier, make life easier for philatelists and collectors to be able to kind of put those stamps in kind of distinct buckets. After that, in addition to that, there were no distinct printings, same plates were used, so that all makes it very difficult to classify them in periods. One unique thing that they had at the back, we're going to talk a little about this in a little bit, is that they had control figures or control numbers printed at the back of the stamp. This feature is unique to the philatelic world, as far as I know, and it will show us another means of classifying the stamps. It helps classifying them as well. Now, here's just a quick succession of printings. The first printing was done in 1861 in Paris. The plates were then shipped along with the first batch of stamps of all denominations were shipped to Athens. And from 1861 to 62, we had the first provisional Athens printings that were kind of not very good. But then the next year, 1862, is when we had the transitional printings, previously known as May 1862, which were very neatly printed, Athens printed stamps. After that, we started the consecutive definitive printings, which usually constitutes the bulk of the later period after the transitional. There were consecutive printings of stamps that gradually were made worse than the transitional ones. I'm not going to talk details about the other periods as well, just for you to know that there's a lot of periods. And as we said, all these periods were mostly created by philatelists to be able for us to be able to classify in some kind of sensible way Hermes head stamps, the large Hermes head stamps. Now we go to the control figures that we just mentioned a little bit ago. So all denominations excluding the 1 and 2 lepta, and let me go back to tell you that there were several denominations in the large Hermes head stamps, which would be 1, 2, 5, 10, 20, 40, and 80 in the beginning, and then 30 and 60 lepta. So all the denominations excluding 1, 2 lepta, and 30 and 60 had control numbers at the back, except for the very last Athens printings of 1880 to 1886. There are several reasons that have been proposed why this happens. There's no documentation, as it usually happens with Hermes heads. There's no documentation of why this was done. But in the end, this proved essential for our understanding and of the chronological series of the printings, because distinct features of these control numbers, control figures, help us, in addition to the front, identify printing periods for the stamps. So long story short, by looking at the control figures, many times we can understand where this stamp can be classified in terms of printing. We're not going to go into much detail about the printings and how they look like. It's just that, long story short, I would say 1861 was the Paris printing, which was very good printing. We were printed in Paris by experienced experienced printers at the time. Then the plates were shipped to Athens, where the first printing started. Initially, they were coarse. Then they went fine, as you can see, 1862, and then moved on to different, let's say, outcomes depending on how clean the plates were and how good the printers were at their work. So this is the first years of the printings. Later on, you can see different outcomes, different, let's say, variations of color or shades depending on the ink mixtures that were used at each specific printing. 1876, Greece joined the UPU, so 30 lepta stamps were printed as a result. Printings continued 1875 to 1880, and the last printings were 1880 to 1886, where in this case there were no control figures at the back, and these were the last printings of the large Hermes heads. They were followed by the small Hermes heads. Now, what are the problems with classifying Hermes head stamps? As I said, they were continuously printed. There were no distinct printings. We could not, it was the same design, same plate, so very difficult to identify the stamps. However, there's other problems as well. I want to center this. I want to focus on the bibliography part, which is the most thorny, which is all Hermes Heads what has been written about classifying Hermes Head stamps is usually written either Greek or French. So there are very few studies in English that can help with people that don't know Greek or French to be able to understand how classification works in large Hermes heads. The other problem is that most of these are very old and not updated. For example, the study or etude in French that was written in 1933, believe it or not, it's still the Bible of large Hermes heads classification. Bibliography, almost like 90 years, more than 90 years ago. There were other studies written afterwards in English from Kunderos, Kaliga, and others. However, they were more focused on more specific things or more difficult to procure, as I write in the third bullet. And most importantly, they were lacking clear picture. Most of the studies, like the study in 1933 or other in 1960s, 70s, 80s, and 90s, they didn't have clear pictures. So they would have very important and very descriptive text of how to classify large Hermes head stamps, but the text could not be matched to any pictures that would help the collector understand what the text was referring to. So long story short, a significant time investment was required. It is required by anybody to get access to classification related material, to get books that will help them classify the stamps. And this is how the AI project started as well. I wanted to have another way of classifying Hermes head stamps, not for me, because I kind of knew how to do that, but for others, to show others how this can be done without access to bibliography and with only access to technology. The last bullet I want to say is that this is a shameless plug, as we used to say, is that hopefully bibliography issues, problems are going to be solved by a book that I wrote, and it's coming out in May 2024, actually in a few days, which could alleviate all these issues because it's going to have a lot of content from previous studies, as well as new content that was written, along with a lot of pictures, good pictures that will help people understand how to classify the stamps, both by seeing something descriptive in the text and looking at real pictures of the stamps. Now, moving on to the core of the presentation is about artificial intelligence. Artificial intelligence, I think, has been in the news. When I started working at it, it was not yet at the news because it was almost 2 years ago before all these chat applications, AI applications appeared. Now, what is artificial intelligence in practice? Artificial intelligence is based on machine learning, which according to Wikipedia is the study of computer algorithms that can improve automatically through experience and by the use of data. What is the saying is basically you can train a machine to learn specific things. So if you can train a machine to understand the difference in the picture between a dog and a cat, you can probably learn that machine to understand the difference between an 1861 Large Hermes Heads stamp printed in Paris and an 1862 printed in Athens. And lots of companies have different implementations and services in artificial intelligence. What I chose is the company I work for, Microsoft Azure Cognitive Services, and specifically, excuse me, part of the service called computer vision. The computer vision part of that offer can be used to look for specific parts in an image or the whole image. And by giving that service a lot of pictures, you can train that service to be able to identify differences between them. Now, how does it work? How does artificial intelligence works in LHH classification? So there's an engine, as I said, that you can train to learn. So in this specific implementation that I'm going to present you, there's an engine that needs to be trained initially by at least 15 already existing images. And this is 15 per set that you want to train them. So in this case, it would be 15 of a specific denomination of a specific printing. That's how it works. So, for example, we would have 15 images of 1 lepton stamps of 1861, 15 images of 2 lepton stamps in 1861, so 15 images of other denominations from each of all other printings. Now, the images need to be tagged. Tag is important. What is the tag? Is what you tell the service that this image is. So in this case, it would be the printing. 1861, 1861, 62, 67, 62, 67, and so on and so forth. There are 2 ways to train the service. The first is to use the whole image. So the service uses characteristics of the whole image to be trained how to identify similar images, or you can use part of it, like the top left part, or a small part of the face, or the nose, or whatever. It doesn't really matter. Now, when you collect all those images and you give them to the service to be identified, to be trained with, then there's a training session that happens at the background. This training is something that is paid to the user. We don't understand what's going on. It just goes on in the background. The service trains itself, and then they say it's ready. The service says, I'm ready to do now identification. And that's a training part. So when the training is finished, then the image can be any test image that you want, any image from your collection can be classified. And the service will figure out when you upload an image to the service, will understand based on the tag, and will offer you let's say a solution, which in this case is an identification result. Now, to the last bullet, attention, garbage in, garbage out. That's a computer term, which means if you train an artificial intelligence service with the wrong data, you're going to have wrong output, which means if you haven't fully trained the system with very, very correct data, which means correctly classified stamps, then the result of this service's output is going to be wrong identifications. So in order to train the system, somebody with very correctly classified stamps should upload images of these stamps so as to train the service with correct data. That's a very important thing if we want to have the correct results. We're going to do a case study, of course, here. We're not here only to talk and show slides, but to actually see how that thing works. Our case studies will be, and I'm going to show you other things as well, not only this one. We're just going to have a more, I'm going to show you here very specifically one of those, because you need to see how the differences are. Sorry. So in 1861 to 62 printings, which is stamps that I have included in the training set of the service, there were 2 kinds of printings in Athens: coarse printings and fine printings. So the differences from the coarse printing and the fine printings, that the coarse printing had little wavy lines with conjoined dots in what we call the spandrels, the angles here, the triangles here at the top right or at the top left, at the bottom, etc. So these lines and dots within were badly printed. They were kind of whitish. The beard was also coarsely printed. Some interrupted lines, some of them conjoined sometimes. And colors of the stamps were deeper, kind of dull shades, but still deep. In the fine printings, we had different results. It was same printings by the same people, but eventually, because they have started mastering the art of printing stamps, they produce better results. So we call them fine printings. So in these printings, as you can see at the right, the spandrels were much better printed. The dots were not of regular shape. They were not touching too much the wavy lines. The beard, what we call the cheek shading lines, were not badly printed as in the coarse printing, but were nicely printed. Lines were not Lines were only interrupted diagonally, and they were very nicely printed as well. And the blue colors were less deep. So this is how we, in a very short explanation, how we would differentiate between a coarse printing and a fine printing. That's how we know how to do it. When we're going to do that through the artificial intelligence service, the artificial intelligence service won't use, let's say, all these differences that we just said. The idea behind is that the service itself is going to understand these differences by the training we did with the several stamps that we uploaded, and by itself is going to understand these differences, and it's going to have a result out for us. Let's see. Yes. Now we're going to have a demo, so I'm going to stop sharing for now the presentation, and I'm going to actually show you how this thing works. Let me share. Give me one moment. Give me one moment. I want to do something here. Okay. Sorry. Okay. Sure. Okay. So this is the main screen of the what we call, just mentioned before, the custom vision project of the Azure service, the Microsoft Azure service that is used for the identification. Here I have 4 different projects that I had created. The one is based on what we said before, that has been trained with the whole image of the stamp and not specific areas. And the other one has been trained with specific areas on the stamps. So I'm going to show you both. And the third one that I'm going to show you is identification of stamps based on the control figures at the back, which is what we talked about previously. So let's start and show you, let's start from this. And I'm going to show you what this thing has. So these are stamps that I have uploaded to train the system. These are stamps of the 1 lepton denomination and the 20 lepton denomination. The 1 lepton denomination, I have uploaded stamps from the Paris printings, and also have uploaded stamps from the consecutive printings that followed. A little bit later, there were others in between, but for 1 lepton, I selected these 2 eras. For the 20 lepton stamps, I selected, as we said previously in the slide, coarse printings and fine printings. This is the project that we just talked about in the slide. So I'm going to show you, first of all, the coarse printings. These are the training stamps that I use, the 15 stamps that we said that we need to upload. And the here are the fine printing stamps, the other 15 stamps that I uploaded for the fine period. Do the same period, but 2 different printings. So what I have done here is that I have already trained the system to be able to recognize between coarse and fine printings. As I said, training is not something that we can see. It happens in the background. We don't have too much. Actually, we don't have anything to do with the training of the system. You can see there's a button here that says train. We're not going to use it just because we don't have any more stamps for the service right now to train it. And for the reason that it also takes a lot of time in the background that we cannot wait for. And there's no reason to wait because the system, as I said, has already been trained with the stamps that I have already uploaded. Now, what we can do here, since that we have the 20 lepta in both coarse and fine printings already uploaded is that I can do a quick test, which means I can upload a stamp that I have, which is not included in these, and test the system to see if it's going to recognize it. So we can, as you can see, we can either upload an image URL, which means an image that has been already uploaded to somewhere at, some website that exists, or we can browse local files. If we click browse local files, we can upload one of the files that we have here. So here I'm going to upload a coarse 20 lepta stamp. I'm expecting the artificial intelligence system to be able to understand that this is a coarse stamp and identify it as such. So let's see if that will happen. So this is one of those cases where it's a stamp that has actually not a very characteristic color for a coarse stamp, but it's still a coarse stamp. So the probability that the service came out with this is 65.1 being a coarse stamp and 64.7 being a fine. So it's a close call. And the others, of course, are not related. The probability is very small. So, and these are for the other denominations as well. So this is basically a false, completely false result. But as you can see, marginally, the result was correct. But let's look at another one. Let's look at the second coarse stamp here. Now, this is a case where the stamp was identified wrongly because this is not a fine stamp. This is a coarse stamp. So this is one of the cases where identification is wrong. And in these cases, we have to go back and see why this was wrongly identified. There could be many reasons. One of them could be the heavy cancel that kind of made the AI program not understand correctly, or this is a case where the program just didn't recognize it correctly. Let's go to the fine stamps. No, this doesn't work. It's still spinning. I don't know why it is still spinning. Let's select another one. Okay, this one worked correctly. So, I mean quickly. So the probability of this stamp being a fine stamp is 63.5% and 52.7% being coarse. So again, the program is correct. This is a fine provisional stamp. So this has been identified correctly by the program. Let me see if I don't think I have any other 20 lepta stamps to work on. Now let's go back to our projects. And let's go back to object detection. So in this specific case, I have images that have been trained with object detection, which means have been trained not with the image of the whole stamp, but by very specific areas. And you're going to see how that plays out when I start testing them. So again, if we go to each one of them, let's go to one of those. You have seen that I have personally put some rectangles here to guide the AI service into what specific areas it should be looking at if this stamp were to be identified as, for example, in this case, 1870 printing stamps. I have, because the cheek and nape shading lines are very characteristic for the stamps, I focused on that. So in this training model, we don't train the image with the service with a whole image, but we're trying to go to specific areas and tag them as the areas that the AI service should be looking for in terms of training. Let's go to another one also to show you. Let's go to a Paris stamp, for example. In the Paris stamps, you can see in this case that I have specifically selected the cheek shading lines. The reason is that in Paris printings of 1861, the cheek shading lines were characteristically broken, in terms of interrupted, as I would say, and small. So I have selected this specific area for the AI service to be trained at. Let's see if I get another one. Here, the same, and I have used also the part of the head. Let's see something else here. Nothing important here. And one more, this is a more specific example of a 1867, 62, 67 stamp, where it has very characteristic whitish spandrels, which characterize this subcategory of this denomination, and I have included them as well. So I don't want to go further in that. I think you get the concept of training the artificial intelligence service using specific areas of the stamp. Let's try to test now L1 leptodenomination using the training model of object detection and not whole image detection. So this is a Paris stamp. So let's see if it's going to be identified as such. Yes, it was identified as such with a 99.1% probability. You will see now another interesting fact is that it has 3 results from the exact same category. Why does this happen? Why does it give us a result that is the same? It takes us to the same category 3 times. The reason is because it's using object detection. It has given us specific results based on the object area that the AI service understood that is related to this printing. So in the first case, it identified the stamp with a 99.1% probability as a Paris stamp because of the cheek shading lines. And in the second case, because of the whole head image, and at the third, because of the whole, basically, stamp image. In all 3 cases, it was successful. It gave us results for the correct period. Let's try another Paris stamp. Again, we have the correct results based on different areas of detection. It is an 1861 stamp, and the probabilities are high for most of the areas that have been identified. Now let's try another period stamp. Let's try a period that was right after the Paris printing, 1861, 1862. Let's try this one. As you can see here, it was correctly identified as an 1861-62 stamp based on the bigger, let's say, impression of the stamp instead of specific areas. But the probability in 98.3% was high enough, and the result was correct. Let's try another one. This is also predicted correctly. In this case, many areas were used. And as you can see, the probability, again, is very high of this stamp being of this period. Now let's go to the last area of object identification that can happen in large Hermes head stamps, which is, as I said, the control figures or the control numerals of the stamps. I believe I don't have a specific control figure to test in this case. So let me just tell you that, just give you an example. In this case, again, it's a coarse and fine printing. So these are coarse printed control figures, which were more heavily shaded than the fine, and these are the fine printings control figures, which were lighter in shade and lighter in shadowing as well. So in this case, unfortunately, I don't have an example right now to show you, but in this case, also the artificial intelligence program gives mostly correct results because numerals are quite easier to understand the differences between them instead of images as complex as a Large Hermes head stamps are. So this is what I wanted to show you in terms of artificial intelligence. Let me stop the sharing. In terms of a practical artificial intelligence outcome, let me stop the share right now. Lucy, are there any questions that we can answer now? We should answer them at the end of the session.
Hello, Dimitris. Yes, we've had a couple of inquiries, questions popping in. Who have we got in here? We have got one from John Beard, who asks, how does the AI manage with stamps that have more or less color change due to storage conditions, exposure to light, etc.? Good question.
Yeah. So artificial intelligence will cope with what we give them. So shades in this case are not as important for identification as the recto the other recto details. The shades would potentially be a part of the identification process because artificial intelligence will gather any information that we give them. Discolorations potentially could give different results. Unfortunately, I haven't tested that scenario because I haven't uploaded any discolored or let's say worn, weather worn or atmosphere worn stamp to be able to give a specific answer. But I would assume that it would have some potentially some impact on the identification. But if we had more than one to be able to upload it as part of the 15, at least 15 stamp training sets that the service requires, I think it would help the service identify in what kind of period might be. But again, that's not something we can say for sure.
Thank you, Dimitris. There's another question here. Here we go from Matthew Healy, who asks, how does the AI analysis account for the presence of cancels?
Yeah, I think we saw one of the stamps, the one that was failed, that it failed to be recognized correctly, that had a heavy cancel. Cancellations do create problems with artificial intelligence recognition points because it limits the areas that the artificial intelligence service can identify, can actually process and then identify as a specific printing. So in this case, the heavier the cancel, the more difficult it is for the service to be able to identify something. Much the same problem we have as collectors. I mean, there's a very heavily canceled stamp, Large Hermes Head stamp. It's not always easy to classify it. In this case, the object detection method of the stamp would help in the sense that it would be able to AI would be able to focus on in a different area, which is clearer, and it would give a potentially correct result. The reason that the heavily canceled stamp that I showed kind of failed in the beginning was one part of it was that I didn't use object detection, which means I used the whole image of the stamp, and some of these areas were heavily canceled, and that potentially could have led to a false result.
Thank you, Dimitris. I think you've answered the question very thoroughly. If anyone, is there anyone else anything else about the Hermes stamp you'd like to share with us? Do continue. And for everyone who's listening, please continue to submit lots of questions in the Q&A and the chat function. I will keep relaying them to Dimitris as we go on. So Dimitris, do continue.
Sure.
Lovely.
Yeah. Give me one moment to see if I can find something to show on the. Unfortunately, I think I had one of those images about the control figures, but I didn't. But it's not very difficult for me to kind of quickly go on. I'll find one. Just give me a couple of minutes till I do. Yep, I think I found one so that I can use it. Give me one moment. And I'm going to put it here. Okay, so let's see. So let's go back. Let me, I think I'm not sharing something right now. So let me try to share again. Can you all hear me?
Yes, I can hear you, but we can't see
Yeah,
any
sorry.
other screens.
Yeah, there's some kind of problem with my Zoom. Okay, now I got back. It minimized my interface. So let me share again. We're here. Okay. Let me share again and try to do one more test. This time the test is going to happen with the control figure number. This is a coarse control figure number. Let's see if it's going to work and identify it as a coarse instead of fine. Yes, as you can see that with a probability of 83.8%, it identified the control figures at the back of the specific stamp as coarse, and the probabilities of fine is only 16%. In this case, the AI service was correct. As you can see, this control figure is, heavily shaded, which is a very specific characteristic of the control figures of the coarse provisional stamps. And also, it's deeply shaded. The color, the shade is deep, which is also a characteristic of this printings. So in this case, the AI service was successful in being able to identify this control figure. And this means that we can actually, in most of the Hermes head stamps, which do have control figures at the back, we can base our identification in both recto and verso of the stamp instead of using only one, like usually the front of the stamp. We can also go to the back of the stamp, identify the back, and have a more complete and more, let's say, be more sure of the result that we got in terms of identification. Let me stop share again. A few words that I want to say that, of course, the results, as I said in the slideshow, the results of the AI service is going to be as good as the input that we have given it. And of course, also it's mostly not able to be 100% correct in all the results, much as experts are not also 100% correct in what they sometimes give opinion on stamps, right? It's especially in large Hermes Head stamps where it's so complex and sometimes kind of subjective to be able to identify. So in this case, we do expect some false positives or some false negatives. Again, some false results. But the better you train the system, the better the system will be able to understand the results. Now, this was, as you saw it, this was a kind of a monolithic solution that you go to some web browser and you just go and download results. Can we bind this solution to some software that we use for identification? Potentially, yes. The reason is that this service has what we call an API, which is basically an interface that can give you results in the way that you want them. You don't have to go to a website and upload the stamp there and get the result back. You can have the stamp somewhere and you can just, what we call, quote unquote, call the service, and the service will return back with a result. Let me show you. It's not implemented in what I'm going to show you, but I'm just going to show you it as a potential feature of such a program that could use AI. So I'm going to share a database that I have created specifically, a computer database that I have created specifically for Large Hermes Head stamps for my collection. So I'm going to share it, and I can show you a potential use of that technology. So as you can see, this is a custom Large Hermes Head collection specialized database that I have created to be able to inventory my stamps. As you can see in this area, we have front and back. I have images of the stamps, and I have personally identified the stamps in terms of the catalog number, denomination, and printing. All these three could have been easily filled by the AI service if somewhere where somebody was inclined to go and do this integration. So in the real world, let's say there's a program like this one, a database or some other software that helps identify stamps and catalog stamps. So instead of the user or the collector identifying the stamps, we could just go and use the service, the AI service, to do this for us. What we would give the service is the front and potentially the back of the stamp. We would have, let's say, a button here that would say upload. The images would be uploaded, processed by the AI service, and then they would be downloaded. The result of the identification of the AI service would be downloaded and would fill those fields here, the catalog number, potentially the denomination, and the printing. This is one example of how the AI service could be used. This is also one more example. Let's kind of drift a little bit from AI of how technology can be used for our collecting interests. This is, for example, a Microsoft Access database, which I created from scratch and from my needs, because there was no software in the philatelic market that is as specialized as needed for these stamps, which are unique in many, many aspects. So in this case, for example, one thing that I can show you as well is I can show you, for example, there's a paper thickness field here, which measures excuse me, type the result of the paper thickness that you can collect with a micrometer. So I have one of those devices here, and one of those things that you can do is you can measure the thickness of a paper, and with a micrometer you can automatically and wirelessly upload the value. So you cannot see it right now, but I have a micrometer here in my desk, and I can just click a button, and as you can see, the paper thickness was automatically uploaded for me on that field. This is just one more, let's say, how technology can help us in our collecting interests, especially in this kind of specialized fields here, to be able to complete some stamps. So in this case, we could use technology, the AI service, to predict what the stamp is and identify what the stamp is, as well as automatically put the paper thickness and other stuff if we wanted to, like the color matching could also be something that we could be automatically adding to this database. So this is one more example of how this AI service could be used, not specifically on the website that we have seen, but as part of a larger, let's say, initiative, or a larger, or even a different kind of tool that we can use for stamp identification. Let's say a finishing touch is that again, this was focused on Large Hermes Heads. This technology can work for anything else. It can be integrated with other software. But again, what I showed you is just a project. So the more denominations and the more printings that you load, the more difficult it becomes for the system to be able to identify correctly, because it has much more variety now to choose from, and it may have a little bit more false positives. But again, the better the training, the better the identification. That's the whole, I think,
the crucial point of the whole thing.
You may remember that in the beginning that we had this AI chatbots that you would ask something and it would spit out like bad words or unrelated content. That's an prime example of some things that need fine tuning. So when you see issues in AI, it means you need to train it back correctly. Go back and train it correctly. So in this case, you see some issues in AI. Yeah, it might have some inherent issues potentially, but it is all learning, and learning is done by humans. So when humans present correct learning processes in the system is going to respond with better results.
There are more virtual Stampex talks coming to YouTube. You know what to do. Click subscribe now so you don't miss out. See you soon. We hope to see you at our next Stampex show, at Virtual Stampex or in person in London.